Welcome to Competency 18 Practice Test Questions. In this video, we will go over different sample problems from this competency. Number 1. In establishing a direct proof, which one of the following is necessary? A direct proof, if you watch the other videos, we discussed an indirect proof usually starts, well, it does start with a contradiction or what something should not be. I'm saying my cat is black. So a contradiction might be saying my cat is any other color, not necessarily white, but my cat could be brown. So you start with something that it is not. Okay. So let's see here. The statement that verifies the given assumption. Well, then I would say, well, my cat is black. And then I go prove somehow that my cat is, say something about color. So anyway, that won't work. So then we have B, a statement that contradicts a given assumption. Well, I assume my cat is black, so I'm going to start with my cat is brown. So B works. You're assuming something isn't what it is, okay? And let's look at C. A geometric drawing. Here's the first thing you need to know, that when you go to university, they say a picture is not a proof. Although I'll have to argue with them that a good proof should include a picture or diagram, not just a bunch of words no one understands. Anyway, moving on. D, an algebraic explanation. Well, nah, that doesn't make sense. That really doesn't make sense. Okay, let's look at number 2. In the figure to the right, this guy right here, these triangles, CB equals A. Okay, it's marked for you. I wouldn't have had to mark that for you. And AC is 10. Mark that for you. Which one of the following statements should be used to prove indirectly that the area of the triangle ABC is less than 40? Okay, here's the thing. Remember, I said that you're not just saying you're more a contradiction, yes, but more in the sense that you're saying what something isn't, what it cannot be. Okay, so if we're going to prove that triangle, this guy right here, is not an area of 40. Okay, and they are talking about area here. Yeah. Okay, so we're going to say he's less than 40. Okay, so what we're going to do that is something crazy. We can see from the drawing that ABC, the yellow triangle, is not a right triangle. It is not a right triangle. So we're going to start our proof with the fact that it is a right triangle. We're going to go backwards. So if we say this guy right here is a right triangle, then what we're doing is we're going to say that, here, let me make some, that's not going to give me any room here. So let's scoot over here. What we're going to do is we're going to say that 8 times 10, this is going to equal him. That's what we're saying. And we're going to divide it by 2 and say it's 40. We're going to say, okay, if he's 40, then his height right here is 10. Hang on a second. But we have an issue. We know that this height right here, right? So this height right here has to be the height of the large triangle created. So we have to take the large triangle here. I'm going to outline it. Outlined in pink. we're going to say that we have the large one minus this little white right triangle here is going to give us this one. Whoa, hang on a second. What does that tell us? That tells us that that height of AD, this is a contradiction. That in itself can't work. Why can it not work? Because the height of AD is going to be less than 10. If AD is less than 10, then there is no way that this value of 10 of AC is going to be part of the area of the yellow triangle. So we have just proven that there's no way that that can be 40 because AD, the height of the larger one, is less than 10. 10 can't be the height, so it can't equal 40. So there you go. Now that I've said all that mumbo jumbo, let's read our options. Determine the measure of an angle. Did I talk about an angle? No, we did not. Did we? No, we did not. That's an angle. Now, what we did is we determined a restriction for the value of AD, not AB. AB is the long hypotenuse. And if you notice, they share that long hypotenuse there. So no, that can't be it. And you probably, if you took Euclidean geometry, I moved him. Okay. You were taught that, and I'm sure you had to crank out one of those proofs, and you didn't know how to do it at first. I didn't, that's for sure. Okay, let's look at number 3. Which one of the following is an example of a deductive reasoning? Okay, deductive reasoning is starting from a formula or a general situation, and then you're supposed to go get your own detail, like figure out how to go from the general, put in the numbers, and get your solution. Okay, so that's general to specific. All right, so A, the first term of a sequence is 1, the second term is 3, third term. Those are details. So then, thus the nth term, that's general. So that's going backwards. That's actually inductive reasoning, which is the way they want us to teach these days. So no, that's not it. Let's look at B. The sum of the angles of triangle XYZ and the triangle TUV is 80. Therefore, the sum of any triangle is 180. Okay, again, the minute they said any, that's the general. So this one goes from specific to general. That's inductive. Nope. So let's talk about C. And C says all triangles have 4. Okay. The fact that they started with the word all, not triangles, all rectangles have 4 right angles. Since ABCD is a rectangle, that's a specific rectangle. So they are going from general to specific. That's the one we want. But we'll go ahead and look at D. Line L2 has a slope of 5 and L1 has a slope of 4. Line L2 is closer to the appearance of the vertical line, than L1. Okay, those are two detailed situations. Thus, the larger slope of a line, and that will be any line. Oh, here. Okay. The more vertical the line will appear. Well, that is detail to general. So, no, we don't want that one. Number 4. One of 2 given statements is all books in the library are for sale. Suppose the conclusion using deductive reasoning is the book Oliver Twist is for sale. Which one of the following would represent the second given statement? Okay. This kind of confused me. But what we're doing is they're saying deductive, not inductive. So you're going from the general situation to all the books to a detailed book, specific book. Okay, we're going to the detail. Okay, so in between, something has to connect for this last statement to be true. So here are your options. Oliver Twist is a book in the library. Okay, all books are in the library. Oliver Twist is for sale. Okay, that one makes sense. Now, Oliver Twist is not a book in the library. Well, then that's a contradiction. That doesn't make sense. It'll contradict. So I'm going to say that's not going to work. All books for sale are in the library. Well, that's not deductive reasoning. That doesn't follow it because we're going from general to general. No, we need a flow of logic, and that's like two general blanket statements. And then when you read it, they don't make sense. Okay, the last one. Some books for sale are not in the library. Well, that's also like it's not a contradiction, but it is what is not. I'm teetering on that's not going to work. It just it doesn't flow through, and it's again saying what is not happening. We're talking about the library and things being for sale. Some books for sale are not in the library. Well, that just doesn't connect. If that were the case, we would have had to say that the book sale is not in the library. I don't know. It doesn't make sense. All right. This one does, though. It connects everything together and starts from general to specific. All books in the library are for sale. Oliver Twist is a book in the library. The book Oliver Twist is for sale. Why is it for sale? Because it's in the library. Makes sense to me. Okay, but you also have to remember your deductive, and that's which made a couple of the statements actually invalid. Okay, so let's look at here. Number 5. A claim is made that the product of two positive numbers is at least as large as either number. Okay, let me finish reading. I'll get to that. Which one of the following provides a counterexample? Which typo there? A counterexample, meaning shows that our claim is not true. Okay, what are we trying to show? We are trying to show over here. Let's look at number 8. We're trying to say that number 8 has got to be at least as large or larger. It says at least as large. So 8 is less than or equal to 8. Check. 1 is less than or equal to 8. Check. Okay, you see what I'm doing? So then I have to say, let's look at B. I also have to say that 6 is less than or greater than 3. That does not work. So that is not a check. Now, if I put 0.5 there, sure. But this being part how they got to 3, well, that's not going to work. Okay. Now, these others, they work if you put, I'll go ahead and do this in the calculator. Put 10 under the square root. Obviously, it's going to be less than your 20, and then you put your square root. But by this point, we have our answer. But you can go ahead and double check answers. So you can see that that's not a counter example. That's going to be like A. It's going to work. So A can't work. C. Now let's look at D. Right away, I didn't like D because it's already saying it's less than. But I went ahead and measured them up. And yeah, 3 is less than 10 and pi is less than 10. So those don't work. I just didn't like because the less than greater than didn't exactly go with the way they stated it. Either way, we have our our answer, our option. Okay, number 6. What is the primary purpose for a mathematical counterexample? Well, counterexample is showing what we just did. We disproved. We showed one thing, and all you need in a proof, when you're using a counterexample, all you need is one. If you can just show one counterexample, you can disprove the whole claim, everything that's said. Okay, so A, to justify our general claim based on a given set of statements. That's not what we're doing. To provide new examples. Nope, that's what we weren't doing that. That's not what we're doing up here on number 5. C, to provide a different approach to solve a given problem. No, that's not what we're doing. D, to negate a general statement based on a given set of statements. Yes. We're trying to show you're wrong, and that's exactly what we did. Number 7, consider the following 3 statements. 1 plus 1, well, I'm not going to read all that. You can see it. Using deductive reasoning, which one of the following statements would apply? Okay, so what are we doing here? It says inductive reasoning. Well, what do they mean by inductive? They mean we need to look at details. We're already doing that. We're going from these detailed given items, and then we're going to find a formula off of those. Oh, sorry. I need to erase some of my goodies here. Okay, so what are we going to do? We're going to read these and kind of come up with something. But you can already look at these and see that this is going to equal 4, this is 9, and this is 16. That being said, let's look at A. The sum of the first nth consecutive positive odd integers equals n squared. Okay, well, how do they're saying n. What's going on with n? The sum of any okay, right here where it says any, that's not inductive. Or I'm sorry, not inductive. Any. That's clues me off. And then this one says first, this one says any. Wait a minute, let's see. The any consecutive and odd integers is n squared, then C, the sum of the squares of the first. Okay, first off, this is just incorrect. The 1, 3, 5, they're odd numbers. We can observe that. They are not squared. Look at D. It says the sum of the squares of any n. These are not squared. They're not squared. So these two go away. We don't want that. Now let's look at what's going on with A and B. I don't like B, and I'll tell you why I don't like B. That word any. They're saying, looking at our pattern, they're saying that we could start with 5 and 7. Well, does that work? No, it doesn't, because 5 plus 7 is 12. We won't get this n squared pattern. So looks like The only way you're going to get this pattern is if you start with the first and consecutive. This means you must start out with 1 and then go to the next odd number. And you must have a building pattern. You probably studied this particular uh, phenomenon in any courses where you analyze number, anything analytical. Okay, it all depends. Okay, what courses you took. All right, so let's look at number 8. Let's look at this guy all the way up here. Okay, number 8. A study has shown that the measure of a person's reaction time is a function of the average number of hours of sleep per night. Marcus averages 4 hours of sleep per night, and his reaction time is 2.5. There's his hours. Natalie averages 9 hours of sleep per night, and her reaction time is 1.8 seconds. Okay. Based on the data using Y to represent reaction time and X in seconds, and X to represent sleep in hours, which one of the following is the appropriate linear model? Okay. 90% of the time is on the x-axis. So that's why they usually see this. When you read, even if you don't read it fully, you can probably always guess that your hours, minutes, seconds are going to be on your x-axis. Sleep in hours. Okay. Okay. And 2.5 represents an reaction time. So you got to be careful. That's why they're telling you. Okay, so 2.5, and then we have 4, and then we had 9, and the 9, then, okay, 9 hours. Okay. Okay. We're going to do this on our calculator. There is no way we need to do this by hand. So you need stat. Oh. We're already populated. Okay. So let's say we're not. Let's go ahead and clear. If you don't remember how to do that, that's how you do it. You go up, arrow up, push clear, enter, and it'll clear it out. But let's just put 4, enter, 9, enter. Okay. All right. So now we have those populated correctly. I put it in correctly. Now you do second mode. Remember, you got to back out of those. Okay. Then we do stat, but we go over to cal because we're calculating and we need number 4. Now it's already populated with L1 and L2. If you haven't watched the other videos with me, how do you put those in there if they're not there? I'm going to clear it. How do I get it back? Second, number 1, and there you go. Okay, that's great. The frequency list, you don't worry about that. That's for something else. But what we do need to worry about is where it says stored your regression equation. That's what that means. What we just did. So we want to go vars over to the y vars, and we want it on function. Enter, and we're going to put it in y1. Enter again. Enter and enter. Now we could go ahead and answer this question right now off of this. So we see that we need A. Now look, A is our M. Remember y equals mx plus b. So our A needs to be negative 0.14 in front of the x. See, it tells you how to build your equation. Nice, nice. Okay. So here's 2 negatives. We'll keep those. That's A and B. But we're not going to keep C and D because those are positive values, the positive 0.14 in front of the X. We don't want those. But we're going to come over here. Well, it has to be B because this negative 0.14 is not in front of an X. And your B value is wrong. Our B value needs to be 3.06. So that is our answer. Okay, now we need to go to number 9. And we have our calculator set up for number 9. Okay? Referring to the information in number 8, suppose that Brianna averages 7 hours of sleep and her reaction time is 2.2 seconds. Okay. What is the percent of error based on the linear model? Okay, what we do is we go with this actual time she had, okay? And we're going to take the actual time and we will be subtracting that from a value that matches the 7 that's in the calculator, okay? That's 7. If you go look up 7 out of this regression model we built, what would that value of 7 be? Okay, over here on the y side. And then we're going to subtract it, but then we have to divide by our actual time we have. No, not our actual time. I'm sorry. Oh, why is it? Okay. By our time given in the calculator. So here's our actual. We're going to go and subtract the predicted time and divide by the predicted time, which is kind of strange, but that is what we do. Okay. And I think if you watch other videos, I laid this out with a graphic, and it's not exactly we say predicted, but instead of predicted, let's say measured. So the calculator is giving us a measure, and we're going to use that with our actual. So let's go do that instead of hearing me talk. Before we do that, actually, I want you to verify that model is in your calculator. It's in our calculator because we did our vars, okay? So now we have to back out, go second table or graph, see? Now it's already on 7. Let's say that it wasn't on 7. All right. Okay. See how my cursor's on the 7? I'm going to do 99. I'm pushing enter. Notice nothing happens. You have to push second graph again. Look, it's on 99. Oh no, I don't want it on 99. Well, obviously you can tell we can go back and put it back on the 7. And there we go. So we just need to subtract by the 2.08 and divide by the 2.08. Okay, again, notice we're taking our actual value and subtracting and dividing by our measured. It's measured or predicted out of the calculator. Anyway, let's back out of that and do 2.2 minus 2.08. Okay, enter, divide, 2.08, enter again. That looks like an option, but I am going to go ahead and multiply that by 100. Okay. Now I can see with a little rounding that option D is what we need. Okay, that was the last question in this practice test. And by the way, I will be making more of these. Please go look at my channel to see when things go up. There will be other items and practice tests. And thank you so much for watching. And if you really like what I've done and my other videos, could you please subscribe to the channel and give us a thumbs up? And thank you for watching.